Hey guys, welcome to my third video on the molecules and matter topic. Today we're going to be looking at changes of state. So last video I stated the names of the changes of state up here, but today we're going to be looking at the changes of state in a little bit more detail. So every substance has a fixed melting and a fixed boiling point. So let's use the example of water. Its melting point is 0 degrees centigrade, so this means that if you had an ice cube and heated it to 0 degrees centigrade, it would start turning into water, and it has a boiling point of 100 degrees centigrade, which means that if you had a glass of water and heated it to 100 degrees centigrade, it would start to evaporate. Now, when a substance is changing state, if I were to draw a graph of the temperature in a substance, it would look a little bit like this, and the flat bits are where the plateaus are where it's changing state. Now you might think, why is it not changing temperature even though I'm adding more energy into it? And the reason for this is it's a solid here and it's going up, you're heating it up, but when it gets to here, it's got enough energy to change state. So what happens is it uses that energy, instead of trying to raise its temperature, it uses that energy to start to weaken those intermolecular bonds so it can change state into a liquid. Here it's a liquid and it's gaining temperature, and here it has enough heat energy to start to weaken those intermolecular bonds further, and it's a gas here. Now, the specific latent heat of a substance is what we use to calculate the amount of energy needed to get it to change state. So the latent heat, latent means hidden, so this is the hidden heat or the hidden energy that you are putting into the substance to get it to change state. And this is useful because it means we can calculate how much energy is going into this substance to get it to change state. So how you would work out the overall energy transfer is you would calculate how much energy is needed to do this, to get it to rise at temperature here, here, and here. Then you would get to work out, using its latent heat, how much energy is needed here and here, and you'd add them all together. Now, we are going to be looking at that more in depth later, as well as specific heat capacity, which is to do with how much energy is needed to raise 1 kilogram of a substance by 1 degree centigrade. Well, that's all for this video. I hope it was of great help to you, and I'll be doing more of these in the future, so bye for now.